and I'm recording. So what we've got is we've got this investigation 2, positive and negative bases for exponents, and it's a criterion B assessment type task. So the idea is that I don't tell you what to do. I don't tell you how to do the next things. You have to try and spot the patterns and see whether you can determine a general rule, something that you can say to someone, oh, well, if it's like this, you always do that. And if it's like this, you do something different. All right. So that's why you've got these pieces of information that have been given to you. All right. And you've got to find the value of each one. It just checks that you know what these exponents mean. And then we had to generalize your results, write down a rule related to the result of raising a positive and negative number to an exponent, and then verify your rule with 2 more examples of your own choosing. Okay, so what we really want to do today is look at this generalize and verify and hopefully justify why your rule works, because I've given this another sheet that I've just put on Teams for you. I didn't sort of highlight it to you, but it is there. I'm trying to come up with, it needs to be changed, you see, at times, but I've tried to give you an idea. These are the strands for a 7 to 8 level criterion B, M2 and M3. So I've tried to give you a sheet that you can kind of, that will guide you through a criterion B assessment. Okay, so first off, it says follow the instructions given in the task. I've just said if you do it in an organized way, showing you're working, you might see some patterns. So if you're not particularly very organized and you just scribble all over the place or do it bits in your head, you probably struggle to see the patterns. And then show that working that you did and identify any patterns that you can see. All right. So first off, we're going to have a look at this investigation then, and we're looking at the value of each one of these. Now, how were you with those, working out those values? You're good. I know I had one question. We sorted that out. Did everyone understand what it means to have these exponents here, the small numbers? Yeah, okay. So let's just have a look then. It starts off with 2 to the power of 2, which is what? 4. 2 to the power of 3? 2 to the power of 4. 2 to the power of, oh, sorry. 2 to the power of 5. Cool. Right, so we've worked those out. All right, and then it said 3 to the power of 2. Nope. 9.
Yeah.
3 to the power of 3.
27.
3 to the power of 4.
81.
3 to the power of 5.
243.
Okay, cool. Looks like you know what you're doing. 4 to the power of 2. 4 to the power of 3. 4 to the power of 4.
56.
And 4 to the power of 5.
1024.
So,
And there was also one more at the end of them, so it went 2 to the power of 6 and then 3 to the power of 6.
cool. Okay. I just haven't bothered. I'm just checking that you got all those as far as I need to go, but thanks for that. So there was an extra one. It didn't really add, I guess, to the pattern up here, but it might do down here. So you went as far as those. Just check you understand what the exponents were. Let's have a look at these negatives though. All right. So negative 1 to the power of 2 is positive 1. And then it was negative 1 to the power of 3. Yep. Negative 1 to the power of 4. Negative 1 to the power of 5. And now we'll go to this power of 6. Negative 1 to the power of 6. Positive 1. Okay, let's just check. Negative 2, negative 3. Okay, so we're just following their pattern. So what's negative 2 to the power of 2? Pardon?
Negative 4.
Afraid not.
Positive 4.
It's positive 4, yeah. Negative 2 to the power of 3. Okay. Negative 2 to the power of 4. Negative 2 to the power of 5. Negative 2 to the power of 6. Okay. Now, there is a potential issue if you put these into your calculator and just type in negative 3 to the power of 2, for instance, your calculator will tell you negative 9, which is incorrect. Does anyone know why your calculator will tell you that? Because we know that negative 3 with brackets to the power of 2 is actually positive 9. So do you know why your calculator would tell you the supposed wrong answer? Does that mean your calculator is wrong or you're wrong?
It's just like your calculator thinks you're trying to do something else than what you're actually trying to do.
Yeah, I mean, you're right. What rules does your calculator always follow? Yeah. How do you use it? BEDMAS, BEDMAS. So it will do E for exponents first. So it does this bit first, and then it will do any additional subtraction. So it considers the negative sign a subtraction. So it will do the 3 squared bit first, and then it will do the negative 9 bit afterwards, which is why you get a negative number. Now, I will tell you this now, and I reckon at least one of you will still do this when you get to DP1 or even DP2. I still get people make this mistake in their calculation, because what they do is they just chuck things straight into their calculator and they don't really think about it. They trust their calculator over their own brain. Okay, so we must be careful about this one. All right, now what we really need to know then is it says follow the instructions, show your working, do you spot any patterns? All right, so do you spot any patterns? So let's have a look at the question. It says generalize your results and write down a rule related to the result of raising a positive and a negative base to an exponent. So which numbers are the bases? Yeah, so 2's a base there, 3's a base there, 4's a base, negative 1's a base. I'm going to have to change that setting now. I need to get rid of that, don't I? Does that work better? Yeah. So these are the bases. Okay. So the question is there a rule? Can you generalize a rule? All right, for raising a positive and a negative. So what you're doing now is you're looking at all of these results. So basically, I only went as far as that. So we're looking at all of these results, and can I generalize anything? So that's the criterion B part of it. Right. So did any of you notice anything? Any patterns that you might spot? Anything that you can say, this is always true?
The negative numbers, it switches from positive to negative on each one.
Yes, it does. Definitely. Can we go any further with that? Could you sort of add any detail to that? So I definitely agree with the negatives, look, right? So you've got the negative base on all of those. It does swap, the value goes from negative to positive, negative.
Odd numbers are negative.
There you go.
Odd, what they call the little numbers.
What are they called, guys?
Exponents.
Yeah. So the odd exponents give me a negative. By the way, I can see people putting chats and raising it. Just speak out, guys, because I'm sharing my screen. I don't really see it very well. So just speak up. So yeah, the odd exponents give me a negative result. Is that always true, or is that only for negative bases? Only for negative bases. Is there a general rule you can spot for positive bases? So all of these ones. Yeah.
Look at the first exponent, 2 to the power of 2.
Yeah.
That gives you 4. And if you want to keep going to get like 2 to the power of 3 and 2 to the power of 4, then all you have to do is times 4 by 2, and then it gives you 8. Then 8 by 2, then it gives you 16. 16 by 2 gives you 32, and on.
Yeah. Yeah, definitely. You're right there. That's how we can do that quickly, isn't it? So you just multiply by 2, and these are just multiplied by 3 every time. Definitely. I've got a question for you there, Nico. So what you've spotted is perfectly valid and perfectly reasonable. Just thinking back to the pattern we've spotted here, though, about...
It wouldn't work there.
Okay, so, I mean, I'm not saying it, but is it in the same area of mathematics? Are we looking at the same sort of pattern? So, for instance, in this one, we've spotted that it goes positive, negative for results. Is there anything just looking at signs, positives and negatives, that you can say for this lot? Is actually super, it's almost like not even worth saying, but it is a valid thing to say. It's all positive. That's it, yeah. Do you all see that, guys? It's almost too easy. It's almost not worth saying. But as Nico was saying, the structure of it is true. Like you multiply by 2. So to carry on, you multiply by 2. Carry on this one, you multiply by 3. To carry on this one, you multiply by 4. And to carry on these, is it different, or do you still just multiply by -1 every time? Is this one just multiply by -2 every time?
You still do keep multiplying by like -2, but like the answers will be different.
Yeah, so you just carry it on, don't you? Like you're saying, just the base, you just multiply. Okay, to carry it on, you just multiply by the base another time. Okay, so we've spotted a couple of things. There's not going to be much to spot. It's a pretty simple task, this. But what we're doing is we're looking at our criterion B components. So let's go back to this sheet here. says follow the instructions. You might see some patterns. Show that working, identify any patterns. So what we've done here in my sheet, I could write, well, 3 squared is 9, and then 3 cubed is, we could do 9 times 3, which is 27, and then 3 to the power of 4 is 27 times 3, which is 81, and then 3 to the power of 5 is 81 times 3, which is equal to, what is it again? Okay, all right. So you can spot that. You can say show your work and identify. So you've spotted that it's just timesing by 3. Okay, so we can write down to continue, multiply by the base again. All right, that was one thing we spotted, but probably the main thing that we spotted was the other thing, which is, right, if you do -2 and we compare that to 2, so -2 squared and 2 squared, what's that? What's -2 squared? And 2 squared is 4. And then -2 cubed is, and 2 cubed is 8, and -2 to the power of 4 is, and -2 to the power of 5 is -32. So what pattern did we spot? I think someone was telling me. We could say if the base is negative, okay,
Even integer, not on even exponents, the result will be positive. But
yeah.
On exponents, it'll be negative.
So you're exactly right, and I don't want to shut you down because you're exactly right. But what I'm going to do, I'm just going to point here just to help you. It says identify any patterns, but then in the next bit it said describe the pattern in some way that we can use it. So what I'm going to do first, right, I can say if the base is negative, the sign changes each time from positive to negative. Does that make sense? And I could just say if base is positive,
The answer stays positive.
it's always positive. Okay. So that's kind of like the first stage. It's just identifying any patterns that you notice. Does that make sense to everyone, how the structure of this criterion B is going? Everyone, good? Anyone got any questions at this point? No? I will carry on then. So what we then do is we need to describe the patterns for strand 2, describe them as relationships or general rules. So what did we say? So we want to focus on negative bases. And what were you saying, David? What was the general rule? If the exponent is even,
then the answer will be positive.
The answer will be positive. But if the exponent is odd, the answer will be negative. How do you all feel about that? Does that make sense? The negative bases. Anyone got any questions? Have you got any comments? Is that all good? Does it make sense? Thank you, David. I know it makes sense to you. Anyone else? Thank you. Yeah, that's better. Okay. So what about positive bases? We could say that. This one's nice and simple and quick. What can we say about positive bases?
Positive.
Always positive, exactly. Nice and short. All right. Odd or even exponents. So what we've done here, guys, is we have described our pattern as a relationship or a general rule consistent with our findings. So just checking, is what we've written here consistent with what we wrote here and what we did in our workings up here? Is that all? The word consistent means that's what I've seen. I've got evidence of that. I haven't made anything up. Does that make sense? We've followed on nicely. Yeah. Okay. Let's try and, so we've described the patterns. All right. We've tried to explain it in a way that someone else can use to complete the problem for themselves. All right. So this is where we start getting to important stuff. It said, verify these rules. So going back up to the question, it says, verify your rule for 2 more examples of your own choosing. Okay. Now, what this should mean, when you verify, it says use your rule with one of the examples that you're already given, not one that you had to work out yourself. All right, and check your method gives the same answer that you were already given. What we've then got to do, and this is where I've got to adjust the sheet, is we've got to test it with our own and see what it comes up with. Okay, so what do you think that means, this statement that you have to do to verify the relationship, verify what you've just said? What would you do?
Examples of the rule, like.
So go on then, give me one that you would write down in this slot now.
Like, -4 to the power of 7 is negative 16,384.
Okay, so you're looking at this, all right, and what we're going to do is we're going to show that that is -4 multiplied by -4. Sorry, that says positive, I didn't mean to. -4 multiplied by -4. You picked a big one, but it was your choice. And we wrote that. What did you say the answer was?
16,384.
Okay, so what did my rule say? Well, my rule said, so 7 is an odd exponent. The answer should be what? Negative, that's it, yeah? And we can say negative 16,384 is indeed negative. You don't have to write the word indeed. You just put is negative, right? My rule works, all right? It does say, give me another one that would also follow the rule. What would you choose next?
Down -4 to the power of 10.
Okay, why did you choose -4 to the power of 10 this time?
I didn't feel like writing 8.
Okay, but why 10? Why not 9?
Because 9 is also odd.
Okay, good. So we picked an odd one. 10 is even, right? And we could say this should be positive, yeah? Negative 4 to the power of 10 is what?
Times negative 4 10 times.
Yeah, we've done that. So what should we just put the answer? It's going to be quite a big number, isn't it? So what is it?
It's positive 1,048,576.
Yeah? So it is positive. It follows my rule. So I have shown that verify the general rule, so it works. And another one we probably should do, because we also stated that if the base is positive, so if we did 5 to the power of 5 or 5 to the power of 6, so that's odd and that's even, they should both be positive, right? So what's 5 to the power of 5?
3,125.
And what's 5 to the power of 6?
625.
And we can say that they are both positive. So again, that sticks by my rule. I've only got a bit of time left, but we're getting through it. How does that seem at the moment, guys? Good? Right, here's the tough bit. So the tough bit. Try to give a reason why your general rule works. So let's look at negative 3 to the power of 5 and negative 3 to the power of 6. Why does this one, why is it negative and why is this one positive? Any ideas?
Negative times a negative is a positive.
Okay.
But
if I write this out, look, negative 3 multiplied by negative 3 multiplied by negative 3 multiplied by negative 3 multiplied by negative 3. If I compare them off, okay, two negatives equals positive. So in this case, it's quite a simple one, this. Those two negatives make a positive. Those two negatives make a positive. But because it's an odd exponent, this one makes the whole thing negative again. Okay? Whereas, if I do this one, look, I've got negative 3 multiplied by negative 3 multiplied by negative 3, negative 3, negative 3 times negative 3. This time, I've got one pair, another pair, and another pair. So this pair will make a positive, this pair will make a positive, and this pair will make a positive. Okay, and a positive multiplied by a positive will always equal a positive. Whereas in this one, a positive multiplied by a positive, but then multiplied by a negative, will equal a negative. Okay, so I haven't used many words there, you might want to do, but I've used diagrams nicely. Okay, so I have justified why my rule would work. There's an odd number of negatives, but why would it work for positives? What do you need to make the result of a multiplication negative? A negative number, yeah. So if I've got a positive base like 2 to the power of 3, I'm never going to have a negative. Yeah, it's always just positives. So I've got no negatives available. So it can never be negative. So I've explained that bit as well. All right. So what I've just shown you here using that worksheet is you were given a task, which is a criterion B task. This part about working out the values wasn't really a particularly big part of the problem. These generalize, verify and justify, that's where the marks come from. Okay, look, strand 1, you have to show how to work it out, but you do have to spot a pattern. Strand 2 is about explaining the pattern. Strand 3 is about verifying that your rule works. Okay, and strand 4 is justifying why it works. Now, all of this is a level 7 or 8. Obviously, if you drop down the levels, you'll have done less than that. Okay. Any questions on that kind of approach to a criterion B assessment? No? Okay, I'm going to stop sharing. Sam's grinning. He's obviously doing something he shouldn't be. He's on the chat. All right, now the reason why I've gone through that, guys, I provided that sheet, I've put that on Teams, is because next week your next task will be to do a criterion B assessment. And I'm actually going, it's kind of going to be a formative practice B, all right, but it's still going to be recorded as a criterion B, all right. I'm going to record it as your first grade of the year coming in quite quickly. So I've given you that sheet, so feel free to use that sheet when I tell you what task to do, but go through that structure, and then I'm actually going to mark it quite harshly. I'm going to, you know, if you don't describe, I hope you're paying attention, guys. You know, I hope you're paying attention, Sammy. So you're going to have a task, criterion B, you're going to go through that sheet, through that process, see how you do in a decent criterion B assessment practice. And that's going to be for basically our first lesson next week. All good? Any particular questions on that? I've got you on video, Sammy, by the way. It's still recording. Need to stop recording. All right. Any questions or anything before I let you go? No? Okay. Nico, did you put your hand up? Do you have a question? Or is that from before?